then we did some investigation on the crack parameter and its effects on the behavior of cracks beam. And finally, so you know, for the idea of our research based on the failure phenomenon on Van Bridge. You all know a very big bridge in the South Vietnam. So we have a crack, a large crack on the diaphragm of Van Bridge. It's steel diaphragm. So you can see this is a very brittle crack. I mean, no plastic zone on this crack on steel. So it is a very a normal problem. A problem on the crack on the steel material, steel girder. So we suppose that it is some reason for this due to for this crack. First, upon maybe the defect of the material, the influence of welding process, and maybe the brittle behavior of the material. And also other reason from the maybe the existing of the initial cracks on the diaphragm of Van Bridge. So under the loading the effect of contraction process, the diaphragm. So based on this in laboratory scale, and we use a high carbon steel. Also, because we suppose that the high carbon steel, maybe we obtain some crack similar than in the crack in the Van Bridge diaphragm. So as you can see here, we develop in 3D with initial intact same with no crack, and the second beam, and the third beam we make a pre-crack on the under the position of load P. So for the on the three beam, we fabricated from with high carbon steel. I mean very brittle steel material. So you can see here the position and the dimension of crack for millimeter depth, and you can see, and we also we use we put on the experimental work in experimental device in laboratory, and we connect all the sensor, including LVDT and other sensor to computer to record all the behavior of this beam under the static load. And also in the same time, we done numerical simulation with the ANSYS software with the same input parameter of the steel, the considered steel for experimental beam. So we first one we obtain some experimental numerical result, including set intensity factor, correcting damage mode, consisting to mode 1, mode 3, mode 2, and mode 3. And we have some comparison with from the experimental region and numerical region. You can see here for the three type girder, a beam, from two, from three, with no crack, with crack as middle of the girder of the beam and crack under the load position. And so we obtain finally the numerical simulation result. Assume, I mean, are not so different from the experimental one. So to obtain the numerical simulation, we carefully do the material test to obtain the main characteristic of material, such that elastic modulus and fracture energy and other material parameter to input after input material RC program. So we obtain finally the numerical simulation is not so different from the experimental ones. So
1 minute left.
We have damage. Okay. And we also, okay, we had the deflection results of 120 kilonewton, and you can see girder with the person freedom from 0 to 24.67 is the maximum value. We also obtained the state interfactor K1 for the mode 1, which the corresponding to load from 0 to 1, and the color trick right were the meter span giving the rate deflection of the beam, and beam sample with pre-crack as meter of the span from 4, and immediately in the loading position where there is and minimum loading rate. And we also do pre-crack on same, all have a similar dimension with 45 millimeter length corresponding to half a flange width, 4 millimeter width and 3 meter depth. However, the position of crack are different from the transverse direction. And the crack position according to transverse direction did not make significant difference of deflection between same, but took drastic duration of loading capacity. And beam same with crack at the end of the flange were larger, threat anti-factor and far smaller failure loading rate than one with crack and flange. And for the investigation of the crack length with from 1, beam 1 with width of pre-cracks, and from 7, 8, 9 with pre-crack and meter span on bottom side of the beam with length of 45, 60 millimeter and 90 millimeter. You can see here for we obtain the state interfactor of the 3 from
time is up, please.
Okay.
The time is up.
Okay, thank you.
Not enough time for you.
Okay. I give it 1 minute for some conclusion here. But, okay. We get some conclusion. The first one, have some influence on seeing giving we do not obtain at this moment the correct at the same case correct we obtain on the we found on the van concrete, but maybe because we maybe our experimental beam maybe do not fit the real boundary condition of concrete. So I think for this error for this different we will correct in the future. So so thank you. If you don't have enough
thank
time.
you.
Thank you.
Thank you very much for your thing. But I'm sorry that the time is so strictly, so that you can have some apologize for it. So next, maybe because the times, so I would like to I have no question here allowed. So I would like to invite the next presentation, number 1013. The title is Monitoring Electrical Resistivity of Strand Hardening Fiber Reinforced Concrete cementitious composite exposed to the cyclic wetting and drying from Ngọc Thanh Trần. Please go ahead. Is there Ngọc Thanh Trần here? Is there, please, Dr. Chuyên Trần, please withdraw your screen. Withdraw your screen, please. Okay, please, I would like to invite the next presentation of Ngọc Thanh Trần. Maybe Ngọc Thanh Trần is absent. I would like to invite the next presentation, Chen T, from Professor Đức Duy Hồ, electromechanical impedance based pre-stress force monitoring of the pre-stressed concrete structure. Please, is there Professor Đức Duy Hồ here? Maybe Professor Đức Duy Hồ is absent. So we have time for some presentation here. Is there any question about the previous presentation? We have time for it.
I have a question for the previous presentation.
Okay.
Firstly, can you turn back the slide, the previous slide?
Please, Dr. Chuyên Trần, you have some question from the Kiệt Bùi An. Dr. Chuyên Trần, please turn on the screen, and you have a question from
the slide relating to the properties of concrete you apply for the model.
I'm sorry. Probably Dr. Kiệt, you would like to ask
Dr.
Chuyên Trần, isn't it?
The previous presentation.
But he is not here, so
okay.
Please wait for a moment.
Yes.
And take your question later.
Yes.
Okay.
If he is available, I will make a question for him in case instead of
Okay.
presentation.
In order to save the time.
Yes. You
Yes,
can
thank
continue.
you. In order to save the
ahead.
time, I would like to have my presentation for the next. The next presentation is from Tham Hồng Dương. It's me about the presentation 22. Reliability index of a multi-story building, considering the uncertainties of the monitor system. So I have some screen here. Everybody see the screen?
Yes, very clear.
Yes, thank you. Today I would like to introduce my presentation about the reliability index of a multi-story building concerning the uncertainties of the monitor system. The content has 4 parts: the reason for the study, the method, the result, and some conclusion for it. You know that a monitor system supplies data for diagnosing the potential of damage. Data are electronic signals subject to a converted by software. So you can see that there is some uncertainty about the signal, about the software. The problem here, the question here is how the signal with the perturbed mode can affect to the result of the measurement. About the method, you can see in the slide here is the model. This is a multi-story building in 6-story with some time-dependent loading at a certain point here. And there are a lot of damage located randomly or randomly distributed, both in beam and in column. And we want to take the signal from the time domain analysis and frequency domain analysis. So there are 5 factors to be studied here. X1 is the dynamics excitation PT. We have some 2 levels. One is the low frequency excitation, and level 2 is for the higher frequency. X2 is the condition of restraint. X3 is the material stiffness. X4 is the gravity loading. X5 is damage location on beam or on column. Besides, we have 2 uncontrollable factors, that is about the uncertainty of analyzer, and N2 is noise for the signal. It stands for the improperly displayed by recorder. So we have 5 factors with 2 noises to be studied. You know that about the regulation for the crack section, you can see the ACI 318 that the possible uncertainty in the cracked area. For example, we have some beam, the moment of inertia will be different than that of the column. And then about the condition of loading, for example, factor and service load condition, there is some different regulation for it. About the noise, we have some data randomly, that is the formula for it, to make the data noisy. And for solving the problem, we have the 9-step strategy for solution. Stage one is the data collection, and stage 2 will be the post-processing for it. In stage 1, we have model, and then damage pattern DPs, and then factor assignment in order to quantify the uncertainties. The 3 step is the response of the structure with respect to each damage pattern. For perturbed mode, by randomly changing the data, this is very important, and in order to make the data noisy. And 5, collected statistically, the data respond in frequency domain. 6 is to collect data in order to put it into the performance function in order to come into the state 2. Step 2 is to calculate the reliability by using some method. In this study, we use the partial derivative of Taylor expansion series. And step 8 is in order to find out which mode is or which factor is more important, we carried out some analysis of variance. And finally, we have some multivariable regression equation in order to find out the correlation between the reliability index with respect to some damages. We have in this slide, we see the 2 conditions of load and 5 performance functions. We use this here is the traditional Taylor expansion series in order to find out the reliability index. Here is some partial derivative for reliability index computation. About the result, we have at least 8 data set for the calculation. X1 is for PT, X2 is for the support condition, X3 is about the condition of the stiffness, for example, the modulus of elasticity. About the dead load X is X4, and the damage in beam or column is X5. We have 2 cases of the frequency. And about the refer point, we choose 2 about the lateral displacement at joint 21. It's the most left, upper left of the point, and the most sagged element here with seriously damaged. About the analysis, both in time domain and frequency domain, we have some schematic diagram here. And when we have the time domain signals, we have conduct some fast Fourier transformation in order to turn it into the frequency domain. And that we come to some result that with the degradation of the restaurant condition, we have some decrease in the mode of natural frequency. And about the noise, when we perturb the mode, we have recognized that there is no dominant frequency here. Perturbed signal affect seriously the spectral displacement, both in time domain and frequency domain. Perturbed signal also affect weakly about the bending moment, both in time domain and frequency domain. Only 5% perturbed signal can make the frequency vary abnormally. About the noise in the data, you can see here about the low and higher frequency. About the lateral displacement at the most left upper point, we cannot see any dominant frequency here. So the result is the more percentage of noise, the greater number of frequency perturbed, but spectral bending moment is not affected by a noisy signal. About the reliability index, we have 2 limit states, so the calculation is so sophisticated. About the factor load condition, we conduct 2 bending moment at the weakest beams or column and the most eccentric in column. About the unfactor service load condition, we carried out over the most sag deflection of the crack beam and the most displaced lateral drift at the top corner. So the result is, you can see here is the chaos of this order in the frequency domain with both 5% of and 10% of noise or perturbation. In order to calculate the reliability index, we come to the performance function. 5 performance function here is about the bending moment, about the eccentric, about the lateral displacement, about the deflect, and finally about the normal in column with the 5 performance function here. And we conducted it with the reliability index in this table. We come with the multiple variable regression. We have some formula about the reliability index in terms of the restraint, material stiffness, and the loading, both in the location crack. With the very high R-square adjustment, 0.923, can say that this model with 5 factor and 2 noise factor reflect very well to the reliability index. In order to calculate the percentage of contribution, we conduct analysis of variance one-way ANOVA, and we come to the percentage of contribution like this. About the damage location, more than 60, nearly 60% contribution. And that load contribute about 14% of contribution. About material, we have some 13% of contribution. And the least contribution is the excitation. So thank you. We come to conclusion. Noise signal affect the response of displacement than response of the bending moment. Reliability can be estimated from the characteristic of the effect. And about the percentage of contribution, we have the first important is the severity of crack, about the gravity loading on beams, about the material stiffness, about the condition of restraint, and finally, the least contribution is the frequency of the excitation. Thank you very much for your listening and attention. Okay, I have some my presentation. Is there any question about the previous one?
Yeah, Professor Nguyễn Lan, I know you are an expert in this field. Can you ask one question for Professor Nguyễn Dương Hồng Thắm? Professor Nguyễn Lan, are you there?
Yes, he is there.
But I cannot hear anything from him.
Okay. If there is some question about it, please contact via email or contact with the author later. We move on to the next presentation. That is the number 31. Oh, I'm sorry, 29, the identification of the bridge pile vibration parameters by Rayleigh method from the Dr. Nguyễn Hữu Hùng, Đàm Minh Hưng. Please, is there Dr. Hùng here? Oh. Is there Dr. Hùng here? Or some co-author? Okay, in order to save the time, we would like to invite the next presentation, 31, safety evaluation of the billboards when considering the random effect of the design parameters in the southwest region of Vietnam, from Dr. An Hoàng Bắc. Is there An Hoàng Bắc here? Okay, thank you. Please go ahead. Dr. An Hoàng Bắc, please share the screen, please.
Yeah. Oh, sorry. Yeah. Just I share screen.
Yeah.
Oh, wait a minute. Yeah.
Yes, the sound is so nice, but about the screen, we can check here.
Yeah. Okay. Thank you. Yeah. Yes.
Okay, nice.
Okay, nice.
Yeah, very nice. Thank you.
Yes, let's begin.
Okay, go ahead, please.
Yeah. Let's begin. Yeah.
Okay, please go ahead, please. We can't hear the sound on any voices. Dr. An.
Yeah, I have.
But
Yeah.
we cannot hear anything.
Yeah, I can hear. Yeah.
Okay.
Yes. Can you hear the sound?
Cannot hear any sound with the mic.
I'm sorry, Dr. An. We cannot hear the sound. You can hear the sound from you, but not from the presentation.
Oh. Yeah. Let I check it.
Thanks.
Yeah. Yeah. Let me check.
I can hear you, but I cannot hear the presentation.
Cannot hear the sound. Yeah.
Yes.
Just.
You can start again.
Yeah. Just. Wow. Can you hear?
Yes, I can hear you. Everyone hear from him?
And a presentation, you hear presentation yet?
Yes. And go ahead, please.
And the sound from the presentation, you can hear it?
Cannot hear. Cannot hear about the sound. Maybe you can conduct it with your live presentation.
Yeah. Just
because you have time, right?
Yeah. Yes, later I can.
You have time, so you can waiting a little bit. Because,
Yeah. But I share presentation.
I think there's some problem in your microphone.
Can you see presentation now?
But yes, see already. I saw it.
Yeah.
I saw it.
Yeah. Hi everyone. I am An Hoàng Bắc from University of Architecture, Ho Chi Minh City, Vietnam. And my purpose on my presentation is safety evaluation of by boss when considering the random effects of design parameter in the southern region of Vietnam. Yeah. And my reports had 6 parts: introduction, material and method, numerical example, design discussion, and conclusion. And in Vietnam, bypass usually has a larger surface, so the main loss acting on the bypass is the wind load. In the southern region is less affected by typhoon. However, there are thunderstorms from August to December, so the number of the damage billboard tend to increase. And many studies have been researched about the reliability of larger scale structure reliability of construction scaffolding system under windstorm, impacts of wind load on larger plate by boss, damage caused by wind load for building in Vietnam. And this my study proposed a method to analyze the reliability of bypass under wind load. And load user to design bypass structure was from Vietnam standard load and auction design code. In order to evaluate the effect of the wind load, this necessarily determine is the mean and standard deviation. And, as thin material used in is low carbon steel and relative mistake. The structure will be safe when the load effect U is smaller than the strength B in the Formula 2. The objective of reliability theory is to accept probability of failure and to find the necessary condition for its limited magnitude. To analyze reliability assumes that U will be a random variable. Then the margin M have a normal distribution. Margin M equal B minus U in equation 5. And the figure 1 and 2, you consider like mistake function and safety margin and reliability index. And the next we will find reliability of structure and probability of the failure is given from SHM&ES. In fact, UNB maybe not be independent variable. In that case, Monte Carlo method create a set of value of for independent for each basic variable and thereby determine the corresponding value of safety margin M. And the next in the figure 3 and 4, you can see an example. Consider typical bypass. Need load included cell weight of bypass. Wind load is calculated with region 2A. And in the tab 1 2, you can see the input parameter of the bypass analysis and geometric characteristic. The random variable of reliability analyze mean, standard deviation, and coefficient of variation displayed in table 3. For bypass structure, the following condition must be checked. Local buckling of the column, global buckling is stiffness of a structure, and the check results are guaranteed. The analyzed results shows that the most dangerous of bypass is global buckling of a structure. Therefore, this study focused on the global buckling of the structure under random factor in chapter 3 and Lima state HG. And you find you can see the probability density function of yield strength, wind velocity, and white column and
Hello.
And I use Monte Carlo simulation with the n number equal 10 to the power of 5 sample. And the mean standard deviation and coefficient of variation of wind pressure calculated in presented in table 4 and in the figure yeah. 6. Same, so the red line express CV of standard wind speed, blue line express CV of wind pressure. Recognize that the standard deviation of wind pressure increases faster than the standard deviation of the wind speed of 2 to 2.2 times. Analyzing the reliability of the bypass structure in 5 different cases. Display chapter 5. The randomness of a parameter includes the survey is expressed as a coefficient in which a standard deviation of the yield strength with a column thickness is equal to 5% of the mean. A standard deviation of wind load is considered in 6 cases with values from 5% up to 30% of the mean. We can see in chapter 5. And the next in the figure shows probability distribution function of yield strength and stress in structure. And in figure 9, presented the final probability distribution of the case 3 and the safety margin M. And in the figure 10 show the relationship between reliability and standard deviation of wind pressure in 5 safer marginal case with different value. And the next you can see the characteristic of reliability of case with a variable CV of wind load of wind pressure. You can see that when CV wind pressure from 0.1 to reliability decreases rapidly, the damage of the structure is more likely. With the conventional design, the safety margin is usually 0.1 to 0.15. But when considering the randomness of the calculated quantities, this safety margin needs to be increased. It's in conclusion, based on the result of the studies, statistical characteristic of random parameter, such as wind speed, yield strength, and column section property were developed. And the result indicated that small change in wind speed lead to larger change in wind pressure. The Monte Carlo simulation is used to analyze the reliability of with the state function being the global stability condition of the bypass column. In addition, the analysis of random effects due to the column shape, type of load, and dimension parameter continue its subsequent studies. And state management agency needs to have regulation and guideline to evaluate the quality of our bypass over time to ensure safety for society. And some document in I will use in reference. And thank you for listening. Yeah.
Okay, thank you very much for your presentation. Very interesting. We have time for one question? Is there any question about the presentation?
Yes, I have a question.
Yes, please. I would like to invite Dr. Huang Lê.
This topic is very interesting, but I just only see the
Huang Lê, go ahead, please.
Yes, can you hear me?
But can you loudly speak?
Oh, so no question. So I have some
hello?
Comment about not a question to the Dr. Huang An. Yeah. Can you hear me?
Yeah, I can hear. Yeah.
Hello.
Hello. Yeah, I
can you hear me?
Yeah, I hear you.
Okay. Hello, can you hear me, Dr. Huang?
Yeah, I hear you. I hear you. Yeah.
Okay, because I have some earphones, so you cannot hear. I have some comment. You can you have some suggestion or some recommendation about the target reliability index for this very important structure like this.
Yeah.
Especially for the lateral pressure, wind pressure.
Yeah, lateral wind pressure. Yeah.
Yes. Would you please give some suggestion about the target reliability index?
Target reliability index. Yeah, in the my study, I use beta index. Yeah.
Yes.
It's you can see I calculated the beta index. Is from beta index I determine probability of failure structure. Yeah.
Yes, but I don't ask about that. I asked about your suggestion or the value, the recommended value of the target reliability index for very important structure like this.
But in my study, but I compare wind speed from Vietnam Building Code in the PC 2A and Vietnam Standard Code in load reduction 1995. Yes, but when I compare it, I know I realize that in velocity of it's some difference, and because I yeah.
Okay,
because
thank you.
Because I calculated a mean and standard deviation of wind velocity, and from that I calculated the wind pressure on structure.
Okay, thank you.
Yeah.
Thank you.
It's the red line and the blue line on TQ7. I calculated the mean wind speed, and when I consider and with the standard deviation of wind speed. Yeah.
Okay, thank you, Dr. An Hoàng Bắc.
Yeah.
Okay, so the time is for the next presentation. I would like to re-invite the presentation of the 20 electromechanical impedance from Professor Đức Duy Hồ, but the reporter or presenter will be Dr. Trần Hữu Tín Lưu.
Hello.
Okay,
Yeah,
thank you.
Thank you all. Thank you all. Yeah.
Please go ahead.
Hello.
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 Dr. Trần, please share the screen. Okay, thank you.
Hello, everyone. My name is Lưu Trần Hữu Tín. I come from Ho Chi Minh City University of Technology, Vietnam. Today, I am going to talk about electromechanical impedance by bridges for monitoring in rigid current structure. I divide my recitation into 3 parts. The first part is introduction, and the second part is impedance by structure monitoring. The next part is numerical simulation. Finally, I go on to talk about illusion. Now, let's turn to the first part of my talk, which is about introduction. Nowadays, along with our tending development of science and technology, many complex and model civil structure has been built. Looking at the picture, I can see this is a rigid structure, tall building. The tall buildings is a capable tank water tank. However, the occurrence of damage in the process of construction, installation, and operation of civil structure is inevitable. Damage at the cable insurance system given interior. the impedance by damage detection method, which utilize electromechanical impedance reborn is highly effective method. This is a electromechanical interaction between the PCT sensor and the hot structure. The structure is derived by characters such as smart, thickness, damping, and spiral condition. The PCT sensor is derived an electric series with voltage and embarrassed. This is let me indicate MBDA mean absolute percentage liberation in this. Damage indicate and utilize to quantify the change in impedance response before and after the occurrence of structure damage. Before and after the occurrence of damage repeatedly, and the number of data in the considered frequency range for indices of MBDI is the value is greater than 0. The structure is damaged, and is the value is 0. No damage recent. Damage indices to align the occupancy of the register. Artificial neural network. This is a relationship between the artificial neural network, machine learning, and deep learning. It's a conversation between a biological neuron and artificial neuron. An artificial neuron network is both connects by simulation function, transfer function, and output. Artificial neural network to detect the severity of the register. This is a couple and choice system of an reinforcement beam was selected for the numerical simulation. The numerical impedance responses are compared to the corresponding experiment one in an scheme to measure the accuracy and possibility of the simulation. This is a serious negatives. Which is slot 0, 20, 40, and 60. Massive ABDS software was installed to establish final elements model. The cable stem on of the stem was simulation 20,729 snoop and element and combine 14 element. The sparing slide control has an interfere slide was modeling with element solid 45 and the distance sensor was modeling with electromechanical element solid 5 and a run was modeling with the element combine 14. This is impedance response for rejection T0. It is a simulation and experiment. This is the difference of distinguish between simulation and experiment. This result show that the final elements model of the cable stem has a very high reproducibility and can be used to represent the real one in the monitoring of the reservoir. the difference of frequency between simulation and experiment for on K is less than 1%. This is MBDA instead. MBDA index in degree. So damage in degree. Perform the NN to detect the richest slot severity. Richest slot dataset training 0, 20, 40, 60, and hold down 5, 30, 85, and 70. Build the NN in frequency domain 100 input of variable for slot that are not input C1 and C100. The impedance response correspond to frequency position and check a simulation that is lot partition 1 data yield for training W1 data yield for model. It's a structure of ANN's ALB. This is data input T0, T1, T2, T3, T R now, and T1 on the now. This is impedance response to diagnose T1.
You have 2 minutes left.
I would and then success that the occupancy 18.7 to 100 errors. Memory simulation to me English bằng cùng Việt Nam. We check cap on cable as no such T0. There are 5 cable. Cable 1 is slot response impedance responsive. Cable 2, cable 3, cable 4, cable 5. MBDA index in I3. That means is 3. Before I to detect the just large serviceability. How does C1 to C5 input data, output data, error on accuracy of 18.5, 18 to 100. Conclusion: the impedance method for efficient in monitoring and data rejection in reject structure. The numerical impedance response will arrangement with experiments 1. MBDA index show high efficiency when detecting the accuracy and precision of the reject slot in couple choice stem. The ENN network success and the stability of reject slot. Thank you for this session.
Okay, thank you for your interesting presentation. Is there any question for the presentation? Is there any? I think that this is a very complicated research and interesting. Okay, if there is no question about the presentation, I would like to invite the next presentation is the from the title 32, a novel proposal in using viscoelastic model for the bridge condition assessment. I would like to invite Toàn Big Farm. Is there here? Is that Toàn here? Maybe later. I move on to the next presentation, 58. Selecting a construction system with a sustainable structural health preservation to facilitate the evolution architect in hospital building from the Dr. Trần Văn Khải. Professor Trần Văn Khải. Is there Dr. Khải here? Is there anybody, is everybody hear my voice? Hello? 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 Okay, thank you, Professor Boumediene, for replying me. So I would like to move on the next presentation, and then we will come back to the previous presentation who is absent. About the next presentation, 58, oh no, 60, analysis stability of tunnel using the theory distortion strain energy from Dr. Vũ Thị Thùy Giang and Đỗ Như Tráng. Đỗ Như Tráng is the professor. I would like to invite Miss Trang. Hello, 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 Miss Trang. Vũ Thị Thùy Giang. Okay. And next presentation, number 61, multi-utility tunnel, MUT and X application for urban cities in Vietnam from Dr. Vũ Thị Thùy Giang. Okay. I would like to re-invite the presentation of the Nguyễn Hữu Hùng, number 29, identification of the bridge pile vibration parameter by the Rayleigh method. Is there Dr. Hùng here? No. Okay. I would like to move on the next presentation, number 71. The design and implementation of the integrated TOT system for remote monitoring from Dr. Nguyễn Tấn Khôi and Nguyễn Lan. Professor Nguyễn Lan here, but the presentation is the presentation. Okay, please go ahead. I cannot hear your voice, please. Hello? Professor Lan, I cannot hear your voice again. Please check your system or you have some the earphone. You plug out the earphone. Okay. Cannot hear. I cannot hear. Please check it out again. Check out again. Is there anybody hearing the voice of Professor Nguyen Lan? Take it easy. You have time. Okay, no sounds at all. So please check the voice or some audio system. Or if you need time to fix it, so I would like to wait for a moment, and then I will invite the next presentation. Professor Nguyen Lan. Oh, Professor Nguyễn Tấn Khôi here. So, Professor Nguyen Lan.
Oh, hello everyone.
Okay. Let me to have some talk about the presentation of Professor Nguyen Lan. Professor Nguyen Lan, please take time to fix it. And I would like to invite the last presentation from Dr. Tấn Khôi, and you can have time to relax it or to check it. Now, I would like to invite the presentation of Professor Tấn Khôi. Please go ahead. Thank you.
Thank you very much. Do you see my slide, please?
Okay, I saw it already.
Okay. Waiting for my minute. Okay. Oh, I will start my presentation already. Thank you for so much. Hello everyone. I would like to introduce myself as Khôi Nguyễn Tăng from the UT Da Nang University. I'd like to present my topic to design and implement of integrated IoT system for remote monitoring. This is on work between I with Associate Professor Nguyen Lan and other colleagues. The main part of my presentation as follows. First, I will introduce my work. Second, I shall deploy model on integrated system. And third, I will show the experimental results that we have made. The last, I will talk about the conclusion of my topic. First, I will introduce something about my work. As you know, data collection is one of the key processes in every system. And we need to have a support system for real-time data collection in which we can analyze the data to make the best prediction from collected data. So far, many solutions for processing of data collection job based on IoT technology. Also, their solutions have reached interesting results, but it has some problems such as degree solution, not diversify function, architecture heterogeneous, and security problem. Divide from actual research problem, we propose a solution to build an integrated IoT system that allows us to collect the image, camera, environmental information such as temperature, humidity, rainwater sensor, wind speed, etc. In the next session, we are going to talk about the deploy model. And the IoT architecture is designed to make some architectural requirements such as it must have an open architecture and using API library to communicate with many function model in of the system, and system have to collect data from many different diverse IoT devices and have having more important functions such as data management, remote monitoring, and warning. And the system must support setting and retrieving data from system quickly and accurately, and providing sensor communication alarm function to allow users to remotely monitoring in real time and secure transmission data from IoT device to server via mobile network. This IoT system can operate in adverse weather condition and use solar energy power to operating. Come to next slide. Here are our proposed IoT architecture model. This model shows communication flow in IoT system, integrated system. According to the requirement, this architecture model consists three main layers: IoT physical layer, network layer, and service layer. This model uses intermediate network setup, Modbus ATU, Modbus TCP, and MQTT gateway to connect on-device IoT network in the system. And the network for the network layer connect on type of IoT device and network device through standardized protocol such as HTTP, Core IP, MQTT, etc. For the IoT layer, this layer management and communication with on IoT in the system, and this layer has the ability to collect data from surrounding environment through sensor and ability to connect on device based on network technology. The next, we will go to the our experimental result. This is actual deployment plan. The IoT system will be installed in high voltage transmission line tower, and it collects environmental data and sends continuously to the server and to site and the analyze. The system also monitor the corridor of transmission line tower to detect on abnormal event. And the next, there are integrating stations are connected to the cloud-based web server with two nitrogen embedded board to deploy IoT platform, and we use Mongo database because it stores data in the recent format and use internal memory, and data query speed is very fast. Here is the electrical schematic to connect on device based on proposed architecture model. This schema includes main components such as embedded system, MQTT converter, solar power, SAR, acqui, and sensor. This part presents the function of monitoring data from IoT system. Website will be deployed real-time image from each IoT station, temperature, rainwater measurement, and wind speed. Through the analyze the receiver data, the system will send warning based on threshold. This is a graph representing the data received from IoT device like the dry water sensor, wind sensor, and temperature sensor. This is a function to fire detection and in observation area. One of main function of that use artificial intelligence to fire detection in in many contexts to help the remoting management. And the IoT device management function allow user can access to public and private legitimate IoT. User can select any IoT device. Besides, user can download JSON and XML format data to send command to corresponding IoT device. And we will go to part 4 at a conclusion. In this session, we will present some achievements that we received. We have been considered and research new things. Propose IoT architecture to connect on IoT device, IoT gateway, and communication network, and cloud server technology. Propose a solution to set up integrated IoT system in that on IoT are connected and send multi-data to the cloud server. And IoT station have multi-function such as collecting, processing data, and communication with server on cloud platform, and remote management and monitoring. Our integrating IoT system solution is useful in remote management and monitoring, especially in mountainous area and difficult to move and many dangerous places. In future, we will improve this IoT system in many directions, such as expanding function of integrating with other IoT systems, optimizing energy consumption, and apply big data management solution, improving machine learning algorithm, forget the high accuracy, and increasing security level for this system. Now on content of my presentation. Finally, I would like to thank you for your attention. Thank you very much.
Okay, thank you, Dr. Nguyễn Tấn Khôi. I would like to invite some question for the Tấn Khôi. We have time and to discuss about it more about this very practical theme. I have a question for you, Tấn Khôi. You hear me?
Yes.
Yes, thank you. Do you have any countermeasure or some solution for the risk management? I mean that if there is some collapse in the network or some, is there any mean in order to save the data?
For in our system, we just pay attention about how to collect the data from some IoT device like as camera device, temperature, and rainwater. For risk management, I think in the future I will cooperate with Convention to support us to integrate many devices for to get more information in our system.
Okay, thank you. But I think best wishes to your endeavor in your profession in the future. Thank you.
Thank you very much.
Okay, is there any question? Because we have time enough for the discussion. In our session, is there anybody want to have some presentation with my introduction previously? Is there, Okay, we will move on to the next presentation, also from the Professor Nguyen Lan, number 72, Health Monitoring System for Long Span Bridges across the Han River in the Da Nang city. From Professor Nguyen Lan, I would like to invite you, Professor. Thank you. Okay, Professor Nguyen Lan, you tested the system continuously. You tested. I cannot hear any voice from you.
Oh, we have program with the micro lamp.
Yes, it is. Cannot hear from you. Okay. Take it easy. You have time in order to fix it. You have time. Do you want to fix it and have the time for fixing that? Do you want? I will move on to invite the next presentation. We have just only one, the final presentation. Oh, you say that you do not know. Okay, I think that you have some problem about the audio system. So, okay, we have time, and during the time of waiting, I would like to move on the next presentation. Do you want to have time to fix it, Professor? Okay, thank you. Thank you for your cooperation. I would like to invite the last presentation of the president of the session for the number 74, lightweight network communication of the real-world health monitoring system based on BIM model from the Wang Jicheng. Is there Wang Jicheng here? I'm sorry. Is there Wang Jicheng here or some other co-worker, co-author? No. So I have time to have some comment or some discussion over the previous presentations. Is there any opinion or some any recommendation? Okay, we have time, and during the times of waiting, I would like to ask them, is there any person want to put some question over the last presentation? Dr. Kiệt Bùi Anh, can you repeat your question for the first presentation, Dr. Kiệt? Dr. Tấn Khôi.
Yes.
Can you help Professor Nguyễn Lan? Something?
I have a message to him, but
what?
He not respond to me. And please wait some minutes. I will contact by the mobile phone with him.
Okay, no problem. Take it easy. I would like to send a message for him that you.
Yes.
Hello.
Okay, Lan.
Okay, Lan.
Yes.
Professor,
Are you hear me?
Okay, very nice. Thank you for your.
I have
patience.
restart system. Yeah.
Okay, thank you. Go ahead.
Yeah. Are you see my presentation on PowerPoint?
Okay, very nice.
Yes.
Very nice.
First, I will introduce myself. My name is Nguyễn Lan. I am professor in the Da Nang University. And I am Professor Khôi on the one group, research group. Yes. My topic is the health monitoring system for long span bridge across Han River in Da Nang City, Vietnam. The main content is first, the introduction of bridge system on Han River, Da Nang City. Basis for design bridge health monitoring system. Design health monitoring system for Thuận Phước Bridge, Dragon Bridge, and Trang Thị Lý Bridge. Results of updates the finite element module for and defining warning threshold for the monitoring system for bridge. Reasons for structural health monitoring system and conclusion. First, I introduce the system, bridge system in the Han River, Da Nang City. There are many long span bridge in the Han River in Da Nang City, but I introduce for famous for bridge. The first Thuận Phước Bridge here, and the Han Bridge here, and the Dragon Bridge here, and Trang Thị Lý Bridge here. We have installed the health monitoring for 3 bridges. That is the Thuận Phước Bridge, and Dragon Bridge, and Trang Thị Lý Bridge. Basic for design the bridge health monitoring system. The aspect of the health monitoring system include the sensor and data logger, and this is on bridge, and we connect to the data sensor and processing system, and data management system, and the structure system evaluation. This is module normalized in the central control office. There are many, some maybe it's includes some portable data logger used for check sensor, and or we can measure on the construction stage. This is the design system for bridge health monitoring in Thuận Phước Bridge and Dragon Bridge and Trang Thị Lý Bridge. We use the many type of sensor, for example, strain sensor, 2 meter, and temperature sensor, and Y sensor, for example. We connect to the data logger, maybe in the node, and we transfer data to the desktop computer on the bridge, or maybe on the room near bridge, and we transfer data onto the internet, and on the server we can get the data apart from the website, for example here. This is the system for Thuận Phước Bridge. We use the accelerometer sensor and strain gauge, 2 meter, thermistor for the temperature, and anemometer for the weather station, temperature and humidity sensor we use to control the humidity on the anchorage room. Yeah. And this is the position for to install the sensor. A step for the Thung Phước bridge. And this is the graphic user for the software on the desktop and on the website. We can see the online. I can introduce the. Hello, Professor. This is the string for real-time monitoring. This is the software on the desktop for the Thung Phước bridge. I will introduce the accelerometer, and this is the FFG diagram on real time, and is the stress diagram on the Thung Phước bridge, and a 2 meter. 2 meter with on the beam of Thung Phước bridge, and temperature and environment sensor, for example, and some report system. This and this is the system on the website. We can access data from away from the website. I think, for example, for Thung Phước bridge, for the data real time on the wide sensor. Yeah. And the system for Ragong bridge and Chantilly bridge is similar to Thung Phước bridge. Yeah. But for the Ragong bridge, we use another data logger. Yeah. But it is similar for Thung Phước bridge, the Chantilly bridge. And next content we use results of updating finite element model, and to define the warning threshold for the system. We use the monitoring data tool, and we combine to the FEM model. We determine the threshold value for the system. And we check the update FEM model. We based on the vibration data from system. We combine the update FEM model. This is some reason for the analyze update model and threshold warning. Yeah. The conclusion for the presentation is the health monitoring system for Thung Phước bridge, Ragong bridge, and Chantilly bridge has met investor targets. The construction cost of the 3 systems is quite cheap compared to similar system that were private installed by the foreign company. The graphic user interface of the software for the collection, processing, deploy, and alarm built on the lab view environment. Installed on the workstation and monitoring room in the brick field, allow to deploy and warning real-time monitoring data automatic. The analysis reason of the warning threshold based on initial monitoring data and FEM model update techniques, so that reason of brick vibration characteristic is quite constant with the FEM model. The temporal monitoring data in the asphalt concrete laser in the Thung Phước bridge is sometimes up to 65 degree, which is temperature that can damage the asphalt concrete when passing heavy vehicle load. Further research work should continue to automatic updating FEM model according to the optimization algorithm and damage detection based on monitoring data. And we have some suggestion. Actually, there are no standard in Vietnam for structural health monitoring. And we suggest we can study to some standard in foreign can use in Vietnam. Thank you for attention.
Okay, thank you, Professor Lan Nguyen, for your interesting presentation. We have a heap of amount of time to discuss and have a question. Is there any person have the question for the Professor Nguyen Lan? Is there anybody?
Yes.
Yes, please.
Yes. I am very interested in this presentation. I have a question. I don't know what result did you recall by you set up the sensor or the displayment in the brick. What is result? What the type of result?
The strength, very simple. The strength, first the strength, and the two matter. It means the displacement.
Displacement
and the vibration by the accelerometer.
You can record by the frequency, right?
Yeah. We from the accelerometer we analyze
frequency,
and we can get the frequency. Okay.
How many frequency did you can record? How many frequency?
I can introduce to the directly by here. This is accelerometer data, and this is the FFT diagram. We can get the frequency on the FFT diagram.
I know, but I want to know how many frequency did you can recall, because if the risk analyzed by the finite element method, I can get the many the frequency, but I don't know how in the real how many frequency did you can recall.
It depends on the signal. We can analyze the signal. We can get maybe the many frequency.
Many frequency. Right?
Yeah.
Yes, because this topic is very interesting, but the advantage you must record the many frequency. If not enough frequency, we can predict the how the damage structure.
I see. That's the difficult to automatic damage detection. Yes, we have used the
element model of the thing.
Yes.
And your intelligent algorithm.
Yeah.
But if you use intelligent algorithm, the data must enough. I mean the frequency must enough. If you can record the MOSFET, it's very good.
Of course.
Call the MOSFET of the brick. It's very best. For the prediction the damage element in the brick.
Thank you. But we can measure the MOSFET with the many accelerometer. Okay.
You can record the MOSFET also, right?
No, not. We cannot measure the MOSFET. We use some sensor, so we can measure the MOSFET.
Okay. Now you just stop at the record the frequency and displacement at the some point, right?
Right. And some environment parameter.
Okay. But the influence of the condition of the environment, I think not enough strong, not enough strong to predict the dynamic element. Just
yeah.
the main result is the frequency and MOSFET or displacement. I think it enough data.
Yeah.
Yes.
We can combine some environment data, for example, temperature and Y data. We can detect sun damage, and we can analyze more. Yeah, more and more. Yeah.
Thank you very much. This topic is very interesting.
Yeah. Thank you.
Yeah.
Thank you. Is there anybody want to put a question for Professor Lan Nguyen? We have time. Oh, I have some question, a small question for Professor Lan Nguyen.
Yeah, yeah.
Yes. Thank you. Very interesting presentation. My interest is in the data. Would you please telling me what is, because you use the accelerometer, because you use the strain gauge, you use the tilt meter.
Yeah.
What is the low frequency mode? So I think that the displacement is very important factor.
Yeah.
So would you please telling me what is the permissible threshold of the perturbation? You know, perturbation, I mean that the noisy in the signal data.
Yeah, noise.
How many percent?
How many percent for noise? Okay.
Allowable signal, about allowable perturbable signal. You know, when the signal is perturbed, that is noisy. How many percent of noise you can accept it?
I can analyze we use some filter on the left view. We filter the noise before we display. Okay.
But in the software you analyze it. You have any algorithm for the filtering it?
Yeah, yeah.
Okay, thank you.
Yeah, thank you.
Is there any question? So the time is for the final presentation is I just recall the author Wang Ziqiang here. Is there Wang Ziqiang here?
Yes, Professor Nguyễn Lan had two papers.
Okay.
Yes.
Nguyễn Lan.
Yes, 1071 and 1072.
72. Okay, Nguyễn Lan has just finished.
I have finished. Okay, thank you.
Yes, okay. So that is the last presentation in our session. I would like to say very thank you for all the participants in our session. Thank you, and wish you all stay safe and good health and success in the future. Thank you. Okay, Dr. Cường.
Yes.
Yeah, I hand out return you the committee organization.
Yes, thank you, Professor Nguyễn Hồng Thẩm. We will finish the section 3, then the schedule.
Yes.
Yes. Thank you, Professor Nguyễn Thẩm. And now we will see you again in the section 4, the geotechnical and geoenvironmental engineering. We will start each sessions at 11:10 a.m. and see you all on the 11:10 a.m. It's after nearly 20 minutes. And
Okay.
see you again.
Thank you.
Yes. Dr. Siguni, are you there? Miss Dr. Siguni Miriam.
Yeah, good morning, Mr. Ryong.
Yeah.
Kong. I'm here.
You remember me?
Yeah.
Yes. I missed you in Belgium. At that time, you wear the red dress, very beautiful.
Thanks.
Yeah. So now just meet together again, but now I'm in Vietnam.
Okay. Good. So I have to start this session, or I have to wait?
Yeah, just wait. I think we will start at 11:10 a.m. After I think 20 minutes. Okay.
Okay.
Let me wait a little bit.
Alo Ngọc Anh, có nghe mình nói không? Alo Ngọc Anh, có nghe mình nói không?
Mình nghe thầy. Alo.
Alo anh,
Hello.
có nghe mình nói không? Tôi không nghe gì. Tôi đang test cái hệ thống âm thanh của tôi á. Alo Ngọc Anh,
I hear.
mà tôi không nghe gì. Nghe mình nói không? Khi mà gắn cái micro, cái headset vô nè, khi mà gắn này vô nè,
Yes.
thì không nghe gì hết. Lý do sao? Alo anh,
Hello.
có nghe mình nói không? Tôi không nghe gì. Tôi đang test cái hệ thống âm thanh của tôi á. Alo Ngọc Anh,
I hear.
mà tôi không nghe gì. Dứt ra thì nghe. I don't know the reason why.
چقدر چایی کن نه فقط بره بیار من حالشم
Chỗ khoa xây dựng nó kêu nó phải ấy không nói khoan. Chỗ khoa xây dựng đó là ý là lộn, chỗ khoa đồng nghiệp đó gửi công văn đi. Đó, nói là phải gửi văn bản trước để phòng tác sinh viên căn cứ trên văn bản đó mới làm cái văn bản gửi qua cho ban cơ bản.
چی بیه؟ Yeah. ایرانی نه ها Mm. Đâu
Hello, Siguni, are you there?
Yeah, I'm here.
And then you can start your sessions. You can now it is 11:15 in Vietnam.
Okay.
Yes, so 5 minutes late.
Is there any participant?
Yeah.
Mm.
So you can start.
Okay. So good morning, everybody, and thanks for being here. I hope that all of you are engaged. So now we start the geotechnical and geoenvironmental session. And the title of the first presentation is a practicable application of steel slag and crushed stone together for road pavement base layer. The author is called Mr. Liam. So are you here, Mr. Liam? I think that there isn't any
Yes,
participant.
Dr. Nguyễn Duy Liêm. Dr. Nguyễn, are you there? Are you here?
Mr. Liam, please. Are you here?
Yes, if not, you can move to the next presentation. Therefore, you can return.
Okay, so the title of the next presentation is Solution for Underground Drainage and Stability of High Embankment Slope at Nan Khu Industrial Zone, Dak Nong, Vietnam. And it will be presented by Mr. Trong Lin Cho. Are you here, Mr.?
Yeah, I don't see.
I think that all the participants aren't here.
I didn't see Linh Châu on this.
We have to wait. I think that we have to wait just 5 minutes.
Okay.
What do you think, Mr. Kong?
Okay, we can wait a little bit. If not, we can move to the next presentation. Thereafter, when we finish everything, we back to the first.
I recorded a video once.
Yes.
Dr. Nguyễn Phước Hùng, are you here?
Yes, I'm here.
Okay, you can move to the next presentation. The paper 1008-5.
So the third presentation will be presented by Mr. Vu Hon.
Yes.
The title is Analyze Vertical and Horizontal Coefficient of Consolidation of Non-B Districts, Soft Soil, Ho Chi Minh City. So you can share your presentation.
May I share my screen?
I recorded my video presentation.
Yeah, can you share your
presentation?
Yeah, it's great.
Video fine.
Okay, can I start?
Yes, you can start.
Yes, thank you.
Or
Okay, good morning, everybody. My name is Phu Hung Quang Nguyen. I'm from Vietnam. Today, I would like to present my paper with the title Analyze Vertical and Horizontal Coefficient Consolidation of Nha Be District of Subsoil, Ho Chi Minh City. In my content, I have 4 parts. The firstly, the introduction. The secondly, a case study. The thirdly, a test results and discussion. And finally, a conclusion. Firstly, introduction. As you know, pre-loading combined with BVDs is one of the efficient soil treatment methods. It can help us save time to treatment. And you know the BVD are installed under the surcharge lot to accelerate the range of the impervious soils and thus speed up the consolidation. You can see in the picture, this is the method. The first picture is when we install the BVD, and the second picture you can see how the water can throughout the subsoil. And in this method, how can we forecast the time, the degree of consolidation or the settlement? In here we have two important parameters. The firstly is coefficient vertical of consolidation, the CV. So this parameter we can determine from the lab testing or field testing. In lab testing, we have 2 tests can determine it. It's oedometer test with 2 methods, Casagran method and Taylor method. And also we can do the series test, the constant rate of strength. And in my paper, I will do the 2 tests and try to compare the results and give some discussion. And the second important parameters is coefficient horizontal of consolidation, GH. In here we have the lab test is rower well test, and the field test is CBTU test. With CBTU test, I also do 3 methods. Firstly is Thayer and Hofsley. The second is CSHM. This means the cavity expansion, critical step, and soil mechanics. And the last one is strand pass method. With 3 methods, I also have 3 results, and we can discuss based on the results. And in my case study, I do my test at the subsoil at the Hiệp Phước Park in Nha Be District, Ho Chi Minh City. This subsoil have a thickness from 10 meters to 45 meters, with almost subsoil is saturated and unconsolidation. The moisture here is very high, in high range from 50% to 100%. And this is my test results. You can see in the graph. In my test result, I do compare the CV 90, CV 50, and CV by series for 3 layers, 1A, 1B, and 1C. You can see the results. And based on my results test, I also have some discussion here. Firstly, CV from odometer test of Casagran method less than Taylor method from 7% to 23%. The Casagran method is just suitable with the normally consolidated soils and over consolidated soil. The link clay with sand and silty clay are difficult to determine by logarithm of time graph. In Taylor method, the square root of time, we just can only provide the exactly CV results from over consolidated soils. The CV result from series test give a less values than the standard odometer test from 17% to 23%. The coefficient of vertical consolidation CVs is decreasing value when the effective vertical stress increase with the correlative depth. And here this is the test result tree graph test result from CV. You can see I do by tree method by using CBTU test S-field. Yeah. I also do the test for 3 layer 1A, 1B, 1 and 1C. You can see. And this is my some discussion here. ER value will increase with the correlative depth when using OCR IB method. Decline trend of GS value in both of the methods. The reason is the reduction of voice ratio. That make more time to dissipate. The CS results from CU test and the relationship by OCR and IB in soil layer 1A, 1B, 1C are not much difference. In the same soil layer, IR value is more growth. The CS value is also more increased. That is demonstrates in results of soil layer 1A, 1B, and 1C. Beside beside definition of CS, SHM methods also have to determine OCR coefficient inside and the contract rate to strain back method. The excess for water cover in CSSM methods and strain back methods is marked to accommodate that have to find the typical CS for the soil layer in Ho Chi Minh City. So I have some conclusion in my paper here. Firstly, in the characteristics of CV, the CV values is elastic phase normally is bigger than plastic phase. When effective pressure is higher than pre-consolidation pressure, then CV is reduced quickly. After this period, the CV value is almost no change. Tunya-based subsoil, the difference of CV value in elastic phase and the plastic phase is about 3.8 and to 8.7 times. When in Tasagi, Peck, and Messi in 1996, the numbers is from 5 to 10 times. The CV results from series test have a small value than our odometer test from 15% to 23%. Suggestion of deformation rate is 0.01% to 0.03% minutes. This number is suitable for the subsoil test in our odometer test. With the suggestion of deformation rate duration when acceptable pressure divides vertical pressure from from 5 to 20% is reasonable. Therefore, the suggestion ratio in ASTM D41S6 S9 is bigger than the ration in subsoil clay in Nhà Bè area. And the last conclusion here, the CCSM method and strain back method have a much more advantage. That's traditional method. The excess bore pressure curve in CCSM method and strain back method is marked to accommodate that have to find the typical CS for soil layer. CS value in CCSM and strain back is smaller than CU test. For safety, CCSM and strain back method should be applied to determine CS in CPTU test. CCSM and strain back method have a much strong point, so it can define historical pressure over consolidation pressure. Almost CS value in three methods is over consolidation rate state. Therefore, the correction set value in over consolidation state to normal consolidation state is very coherency. So this is my presentation. Thank you for your listening. Thank you.
Thank you very much for your nice presentation. Any question, please? So now we will move to the final presentation. The title is Analysis of Increase in Bearing Capacity of Shaft-Grouted Board Piles at a project in Ho Chi Minh. It will be presented by Mr. Tan Dan Tran.
Yeah, thank you.
You're welcome. Can you share your presentation, please?
Yeah, I'm sharing. And can you see my presentation here?
Yeah, it's
so
okay.
Yeah, okay. Thank you. Hello, everybody. My name is Yan, and I'm from Ho Chi Minh City Open University from Vietnam. Today, I would like to present my work about the increase in bearing capacity of shaft-grouted board piles at a project in Ho Chi Minh City. My presentation will have four parts. Firstly, I will introduce the background of my study. After that, the methods and the result obtained. And finally, the conclusion of my work. Now, I will start with my reason of my study. In recent years, with the increase in population and the development of economic, more and more high-rise buildings have been built in Vietnam, especially in the big cities like Hanoi, the capital, and Ho Chi Minh City. And by pile foundation or pour pile is one of the pile times with large low capacities commonly used for these high-rise projects. But in some cases, we need to increase the bearing capacity for the time of piles. And high-rise, high-pressure grouting technology were used in this case. Here are some very new high-rise projects which have board pile or barrettes using shaft grouting technology in Ho Chi Minh City. But however, until now, how to estimate the bearing capacity of this type of pile has not been described with national standards, I mean Vietnamese standards, and this depends entirely on expert of contractor. Therefore, this study will focus on the increase in friction resistance of the shaft-grouted parts compared to the non-grouted parts. And the second purpose, a correlation to estimate the unit friction resistance for this type of parts will be suggested. Now we move to the methods used in this study. In this study, we use the Osterberg cell test data of 2 trial parts from Lancaster Lincoln project, which is a 40 floor and 3 basement building in Ho Chi Minh City in the south of Vietnam. Here are the schematic section of the 2 trial ball parts. The first part called TB01 on the left here, which is non-grouted for comparison in this study. And the second part called TB03, which is sharp grouted from an elevation minus 36 to 85 meter, the pie tips. The 2 pies have the same diameter and length. They both have a diameter of 1.5 meter and a length of 85 meter. You can see here the soil profile at the site consists of 11 layers with mainly sand and clay. And you see here for the TB01, the loading assembly, I mean the O cell, is located at an elevation of minus 60 meter. And for the TB03, it is located at an elevation of 61.5 meters. In addition, the 2 pies were instrumented over its full depth with 15 level of strain gauge here. We have strain gauge level 15 to strain gauge level 1 at the pie tip. For the first purpose, which is to find out how much the increase in friction resistance of the sharp grouted parts compared to the non-grouted part. Firstly, the low displacement curves of the O cell test results of TB01 here on the left and for the TB03 on the right were compared to deduce the increase in mobilized resistance of grouted part compared to the non-grouted parts. Secondly, we use the strain gauge reading over 15 level here to calculate the unit friction resistance along the instrumented segment here of the TB01 and also TB03 parts. After that, these values were compared to deduce the increase in friction resistance of sharp grouted part, I mean the TB03, compared to the non-grouted part, the TB01. Thirdly, we use the finite element method. In this case, is Placid 2D software to extrapolate the ultimate load capacity of TB01 and TB03. This value was compared after that to deduce the increase in ultimate resistance of sharp grouted part compared to non-grouted part. And for the second purpose, the calculated unit friction resistance along the sharp grouted part, the TB03, were back analyzed in correlation with the SPT value of the respective soil layers to deduce a correlation between the two parameters of sharp grouted pile. And now the results of my studies. For the first objective, the increase in friction resistance. Based on the analysis of the low displacement curve of O-cell test on two trial pile. On the left is the TB01 and on the right TB03. The total mobilized load capacity of the TB01 corresponding to the maximum loading increment is 41.78 meganewton. And for the TB03 is 83.42 meganewton. And we know that the two test bars have the same size in length and diameter. Therefore, the grouting method in this case increases 2 times the bearing capacity of the sharp grouted pile, I mean the TB03, compared to the non-grouted pile, the TB01. If we compare the ultimate bearing capacity of the TB01 here and the TB03 here, 86 meganewton, determined by the finite element method, the result shows that the ultimate bearing capacity of the sharp grouted pile is 1.7 times compared to the non-grouted piles. This can be explained that the upper friction resistance as well as the combined and bearing and lower friction resistance have not been fully mobilized in the field test. We can see here just more than 80% of resistance were mobilized in the O-cell test for the TB01 and 97% of resistance mobilized in the O-cell test for the TB03. When we compare the unit friction resistance value calculated along the depth of two test piles, this icon for the TB03 and the circular one is for the TB01. It can be seen that the increase in bearing capacity of the TB03 compared to the TB01 is mainly from the increase at the friction resistance of the soil around the grouted pile segment from an elevation of 36 minus 36 meter to the pile tip. If we compare the total friction resistance here, we can see that the increase in friction resistance in total here is about more than 110%. For the second purpose, the correlation to estimate the unit friction resistance. We got here the relationship unit friction resistance equals to 8.76 value SPT value. And this model suggested by this study to estimate unit friction from the SPT value. And this correlation have been compared with others in the paper in previous study, and with also with the design model of Achi Soletan, contractor in Vietnam, and it is found that this model is consistent with previous study. Now, for the conclusion, the comparison of the bearing capacity determined from the O-cell test up to test pi with the same length and diameter, which one is non-grouted TB01 and the other is sharp grouted TB03 in this study, show that the sharp grouting method increases the sharp resistance of the corresponding pi section by more than 110%, which increases the pi's bearing capacity. And the second one is the correlation here deduced from the back analysis of the cell test, and the SPT result can be used to estimate the unique friction resistance for ball pies using sharp routing technique in the study area, I mean in Ho Chi Minh City. Thank you.
Thank you very much for your interesting presentation. So, any question, please? Is there any question? Okay, thank you. I think that Mr. Dai Lim and Trong Lin Cho aren't here. So we finished the civil and geotechnical session, and I want to thank all the participants. I hope that the next year will be better than this year. Thank you very much.
Thank you.
Thank you, Dr. Miriam. Thank you so much for this session. And we will see you again in the final session. The final session is experimental and numerical investigations for engineering structures. You will start at 12:20.
Sir.
See you on 12:20. See you.
Okay.
Bye-bye.
River.
Yes, Samir, are you there? Are you here?
Yes, Kong, I'm here, yes.
Yeah. Okay.
So, how I can see. Yes. Yes, Kong.
Good afternoon, Samir.
Yeah, hey, hello. Hello. Yes.
How are you today?
Oh, fine, thanks. And you? Oh, it was very tired.
Yesterday we are busy.
Yeah. Too busy.
In the last session.
Yeah, this is the last session. So at 20,
we are prepared it for 1 year ago today.
Yeah, of course.
In the last day for the conference.
Yes, the last day. But next week we'll start again. So it's difficult to.
One, two, three, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have a chair presentation in this section.
Yes, you will be.
Yeah.
Okay. Yes. Okay.
Chair presentation duration in 2 hours. 2 hours.
Yeah, around. I don't know how. Yes, hours. Yeah, around 2 hours. Yeah.
Good afternoon, Khúc Quang Trung.
Hi everyone.
Yeah, I saw you.
I can share the.
Okay. Hello, everybody. This is our session, the last session of this conference. I saw the first presentation, so that we start, this session is started. Right now, in the last session, session number 5. The title of session is Experimental and Numerical Investigation for Engineering Structure. The duration we have a trail presentation. Duration is 2 hours. So that each presentation has 10 minutes, including presentation and Q&A. Okay. Each presentation total in 10 minutes. 10 minutes for according to time duration from the organizer. Now, we would like to first presentation. Chair number 40. The author Khúc Quang Trung. The title of presentation, The Factor Affecting the Toxicity of the Fire Production Involved by Burning Pinacates Wood Material. Mr. Khúc Quang Trung, please.
May I share the document?
Yeah. Okay, I see presentation. Quadruply.
On behalf of our research group, I'm very happy to present about the factors affecting the toxicity of oil products involved by burning PNC wood materials. My presentation consists of three main parts: introduction, experiment, results, and discussions. Okay, nowadays, wood material have been widely used in construction and civil. However, wood materials have a high risk of foreign disposal. When wood materials are burnt, they cause a lot of toxic foreign products. And the toxicity of foreign products can be determined according to the model of efficient gas and the model of irritant gas. In fact, the toxicity of oil products is often determined based on the model with higher value. Now we come to our experimental process. We used the experimental process according to ISO 5659 to determine the toxicity of oil products. Figure 1, you can see this is the procedure for determining the toxicity of oil products generated when burning wood materials on DSC and FTIR device at the University of Oil Prevention and Fighting, Vietnam. Now come to our results. We looked at the results about the toxicity of oil products produced when burning PNC wood material. As we know, we conducted experiments to determine the toxicity of oil products generated when samples of PNC wood materials are burned. The experimental results show that the oil products of burning samples of PNC wood materials consist of various gases such as carbon dioxide, carbon monoxide, tinoxide, etc. The concentration varies over time. From the concentration of the toxic gases, we determine the toxicity of oil products. A burning process of PNC wood materials according to the efficient gas model and irritant gas model. The toxicity of oil products according to the FEC model is much higher than that according to the FED model. Therefore, we choose to determine the toxicity of oil products based on the FEC model. I mean, the irritant gas model. About the factors affecting the toxicity of oil products produced when burning PNC wood materials. We conducted the experiments with 4 different wood samples. These wood types are commonly used in Vietnam, including PNC wood, prunus, arborea wood, talma wood, and Parasharia chinensis wood. Figure 5 shows the toxicity of oil products produced when burning 4 types of wood material. The results indicate that the toxicity of oil products involved when burning PNC wood samples is much higher than that when burning the 3 other samples. To study the impact of heat intensity on the toxicity of oil products, we conducted the experiments on 2 PNC wood samples with different heat intensities. We can see that under the same condition, the higher heat intensity leads to more quickly thermal decomposition of the material, and thus increasing the toxic gas concentration when PNC wood is burned. About the impact of coating material on the toxicity of oil products. We conducted the experiments on 3 PNC wood samples under the following experimental condition. 1 PNC wood sample without coating materials, 1 PNC wood sample painted with PU, and 1 fluoride resistant painted PNC wood sample. We can see that the toxicity of oil products in case of PNC wood sample without coating material is higher than that in case of PNC wood sample painted with PU and the fluoride resistant painted PNC wood sample. We can conclude that the toxicity of oil products generated when burning PNC wood materials according to the irritant gas model was much higher than that according to the efficient gas model. And we investigated the factors affecting the toxicity of oil products generated during the burning process of PNC wood materials, which are the toxicity of oil products produced when burning the PNC wood sample was much higher than that when burning 3 remaining wood samples. And the greater the heat intensity is, the toxicity in oil products produced when burning PNC wood sample without coating material is much higher than that when burning PNC wood samples painted with PU and fluoride resistant paint. Now, it comes to the end of my presentation. Thanks a lot for your listening.
Okay. Thank you for your interesting presentation. And the next programming answer question. The question, please. The question, please. No question.
Only question, okay.
Okay. I have a small question for you. Mr. Khúc Quang Trung, yeah?
Yes.
Okay. Yeah. What is the factor affecting to the toxicity? What is the factor? And the factor is the sensitive, less sensitive.
I think impact the different wood type on the toxicity of five product. The second impact of heat intensity on the toxicity of five products, and last the impact of coating material on the toxicity of five products.
Yeah.
Okay.
Three factor.
Okay, 3 factors.
Okay. What is the factor important to affect on the result?
The last, okay. Impact of coating material on the toxicity of five products. Okay.
Yeah. Okay. Thank you.
Oh, okay.
One more question, please. Okay. Thank you, Khúc Quang Trung, for entering presentation. At the end of this presentation, in the next presentation, the paper number 1051. with the author the same of the first presentation, Khúc Quang Trung. Yeah. Okay. Mr. Khúc Quang Trung, please.
Okay.
Hello everyone, I'm Đỗ Minh Thảo from the University of Foreign Innovation and Quality. On behalf of our research group, I'm going to present about the fabrication of a liquefied petroleum gas leak detection device, a sensor made from anthoperic oxide narrow, tin oxide narrow composites. My presentation consists of three main parts: introduction, experiment, results, and discussion. First, I'd like to talk about why we conducted this research. So as you know, liquefied petroleum gas has become a very important source of fuel for our country. It is commonly used in various fields. However, it is also a source of fuel with a high risk of fire explosion. And we know that gas sensors made from semiconductor metal oxide materials have been commonly used to detect combustible gases and toxic gases. For this reason, we conducted research to fabricate an LPG leak detection device, which is based on a sensor made of anthoperic oxide narrow, tin oxide narrow composites to detect and warn the risks of oil explosion. Now, let's look at our experimental process. Figure 1 shows the synthesis procedure of tin oxide rock material from the mixture of tin tetrachloride, sodium hydroxide by hydrothermal treatment method. To improve the sensitivity of the sensor, the anthoperic oxide tin oxide composite was synthesized by doping anthoperic oxide narrows with tin oxide narrows with different mass ratios. In order to make the sensor components, the above anthoperic oxide tin oxide composite material was rotated on a silicic substrate attached to a common tooth electrode. The sensitivity of the sensor is defined as the ratios of the resistance of the sensor film in the A and the resistance of the sensor film when the test gas appears. Now come to our results. First, the morphology and structure of the material. You can see the TEM image of the standard oxide narrows after thermal treatment at 120 degrees Celsius for 24 hours. Figure 3, C1, C2, and C3 show SEM images of nanostructured anthoperic oxide rocks after thermal treatment at 600 degrees Celsius for 2 hours. The images in figure 3B5, B6, B7 illustrate that tin oxide narrows with a relatively small size tend to stick to anthoperic oxide rocks in the anthoperic oxide tin oxide composite sample, which is clearly shown in TEMB2 image before. The dependence of the sensitivity of the film samples on the working temperature for 1% of LPG is shown in figure 4. The results show that the composite film sample with the ratios of iron tin equal to 75/25 as the highest sensitivity. Figure 5 shows on LPG concentration at 370 degrees Celsius. Well, we designed an LPG liquid detection device based on Frontier software. It consists of 4 basic blocks, as you can see: the power unit, sensor unit, comparison block, alarm and peripheral connecting device unit. As you can see in figure 6, the principal diagram of the warning device. After studying the principal diagram of the device, the printed circuit was designed based on a REST professional item of Frontier 7 professional software program. Figure 7 and 8 illustrate the printed circuit diagram of the LPG leak detection device. The performance of the device was tested after the complete installation. The technical specifications are as you can see in table 1. To summarize, the tin oxide narrows have been successfully synthesized from tin tetrachloride and sodium hydroxide by hydrothermal treatment method. The synthesized rods have a diameter of about 13 nanometer and a length of about 30 nanometer. Besides the ferric oxide, tin oxide nano composites with the dispersions of tin oxide nanorods into ferric oxide nanorods were successfully synthesized by hydrothermal treatment methods. Sensors based on ferric oxide, tin oxide nanorods composite materials have shown good sensitivity to LPG. The results show that the composite film with iron-tin ratio equal to 75/25 has the highest sensitivity with 32 times 370 degrees Celsius. In addition, we have also successfully fabricated an LPG leak detection device based on the sensor made from ferric oxide, tin oxide composite. Okay, so it comes to the end of our presentation. Thanks a lot for your listening.
Thank you. Question, please, to our conference. That topic is related to chemical. Okay, no question. I think that's. I would like to invite one question from the audience. Okay, thank you, author of this presentation, Khúc Quang Trung. Yeah. We have a next presentation, the paper number 1056, three-dimensional study on aerodynamic drag of fusion of composite bridge pylon by finite element methods. Author of this presentation is Nguyễn Văn Mỹ.
Yes, I'm here.
Yeah, okay.
So I'm trying to share my screen, but I think
yeah.
Khúc Quang Trung is to stop your screen, I think.
Yeah. Phan Hoàng Nam.
Yeah.
Yeah. Mr. Phan Hoàng Nam, please.
But I cannot share my screen.
In the last bottom of the screen. You can share screen.
Yeah, but it's already shared by other participants, I think.
Yeah.
So I can participate. I can participation.
Yeah, because the screen already shared by other person. I think Cook Quang Chung, you already share screen.
Yeah, Mr. Cook Quang Trung. Yeah.
No, it's
Right. Yeah. Okay.
Okay.
Okay. Hold on now. Oh, exactly.
It's okay.
Yeah. Okay. I see.
Yeah. So good afternoon, Mr. Chairman, and good afternoon, everybody. My name is Nam Phang from the University of Da Nang. So today I'm going to present our work with the title Three-Dimensional Study on Aerodynamic Drag Coefficient of Cable Stability Pylon by Finite Element Methods. So as you saw in the slide, is very well-known accident of Tacoma Bridge in US in 1940. So this bridge was totally collapsed by the flutter phenomenon. So from this time forward, the aerodynamic instability of a long span bridge, especially cable supported bridge, has been paid more attention in research community. So among cable supported bridge component, the pylon are also the most sensitive component to the dynamic load, especially wind load, because they are tall structure and carry most of superstructure weight. The collapse of the pylon may lead to total collapse of the whole structure. So in the slide,
I recorded my presentation as video file for situation of an internal. I recorded my presentation as video file. I prepared my presentation. I prepared my.
Excuse me.
Yeah.
My presentation file, not presentation, video file, as a video file, as video file, as video.
So everybody watching?
Yeah. I saw overview in the cable side bridge. Yeah, I know.
So now I move to the next slide. In the collapse of the, it's an example of the collapse of the Piazzara bridge in Colombia due to the collapse of the western pylon. So we know, so for the pylon, it's the tall structure and carries most weight of structure. So the collapse of the pylon might lead to the partial collapse or totally collapse of the whole structure. So as we saw in the slide. So with the development of computer techniques, the computational approach known as computational fluid dynamics has been widely used because it's possible to numerically simulate the wind flow and their effect to the whole structure or only component. So as we see from the slide, two examples of the computational fluid model. One is a model of whole structure, for example, with the suspension bridge, and another one is a sectional model for the component. So, so there are some study investigating the aerodynamic force on the bridge pylon using computational fluid dynamic model. However, the influence of different terminal model acquire different shape of the pylon on the aerodynamic
CFD, why the
the present work mainly at simulating the flow field around cable style brick pylon with different shape, which is based on a three-dimensional finite element model. The selection of the optimal turbulent model for the wind flow around the brick pylon is also investigated. Based on the objective, the research content divided into three main parts. The first part, I will introduce the numerical modeling. That's based on the finite element software ANSYS. And in the second part, the numerical research of flow around simple objects and three brick pylon are presented and discussed. And final part is the conclusion of the work. In the slide, we say we can see some aerodynamic force acting on the structure. For example, F line. So we can see there are four forces: it's a lift force, drag force, or side force, or moment pitching. For the bridge pylon, drag force is more important because it's a force structure and it depends on the shape. Based on the finite element ANSYS software, we try to simulate the flow around the structure. And the first structure is a simple object to validate the model, and the second one we try to model with different cable style brick pylon with different shape. To investigate the effectiveness of the pylon shape on the rate coefficient of the structure. The model, the first model of the flow around the simple object is on the slide. We model the simple one to validate the model using some available literature with the experimental data. The inlet boundary is defined with the flow velocity, and the outlet boundary is defined with at the opening condition with the zero pressure. And three flow velocity including 0.1, 0.1, 10, and 20 meters per second are choosing for simulation, and this leading to 15K of simulation. We know in the computational fluid dynamics, the mesh is also very important. To obtain the accuracy mesh for the model, we try to perform the convergence analysis. At the research, we use some verified mesh in the region close to the pylon, and the cost mesh is used too far away of the section. Some numerical research for of the rate coefficient we measure from the computational fluid model for the 5 different shapes of the simple section. It's set the third case, so we mark the red color. So most of the case we have the numerical research. It's very close. The results is very close to the experimental one, and the difference is under 5%. So this demonstrates the accuracy of model, and we can use for the next simulation. In the next simulation, based on some parameter we set for the model of simple objects, we try to develop 3 numerical models for 3 different brick pylons in cable stay brick in Vietnam. That's the Khao Lan Bridge, Vom Cong Bridge, and Trang Thi Li Bridge in Da Nang City. So the schematics of the pylon is shown in the slide, and the flow domain is the same as that of simple object.
Mr. Phan Hoàng Nam, weekly.
Okay. The effects of different turbulent model is also considered in the model. So we try to use a different turbulent model to find the optimal one. At the research, we follow the K omega model and SHC model is the most suitable one to determine the right coefficient of the pilot. And here we have some numerical research at the rack force on the Colon von Kong Chantilly bridge pylon. At the research, we see the rack coefficient of Chantilly bridge is highest among three next to the Colon bridge and von Kong bridge. So the difference of the rack coefficient due to reason. The first one is the pylon shape, and the second one is the flow direction acting on the pylon. And the last figure, I show you some voltage. Voltage is behind the pylon. So we see the first one of the Chantilly bridge. The voltage is very high, and its reason is a sawtooth. It's the of the galloping phenomenon might appear here. So from the simulation, we have some conclusion. The first one is the numerical model is developed and validated with the symbol model, and the results of the numerical modeling are in good agreement with the experimental data. And we also found that the K omega model and shear stress transport turbulent model is more suitable one for modeling the flow around the single bridge pylon. And among three bridge, we found that the rack coefficient of Chantilly bridge is largely one, and followed by Colon bridge and von Kong bridge. And also we found that the galloping phenomenon expected to strongly appear in Chantilly bridge because the high magnitude and direction of the flow in the wet galloping region of pylon. So I finished my presentation.
Yeah.
Thank you for your attention.
Thank you, Mr. Phan Hoàng Nam. Any question? Okay, I have a question. Can you explain the galloping phenomenon in the Chantilly bridge? Why? In the galloping, yeah.
Okay, so any question more?
Yeah. Why? What is the galloping phenomenon when you occur?
And this one we expect to have galloping. So we don't investigate the galloping. So based on the shape of the pylon, for example, in Chantilly bridge, the surface, the area surface is larger than other one, and the second reason is the direction of the flow. It's near perpendicular to the structure. So that's cause very high pressure on the pylon surface, and also it leads to the very high magnitude of the voltage. So
okay, so this topic is very interesting for me. Contact with you after conference. Yeah. Okay. We move next presentation. The paper number 1057 on the representative volume element of denser granular assembly mesh up to this circular particle. Yeah. Nguyễn Trung Kiên, please. Mr. Nguyễn Trung Kiên, please. I don't see Mr. Nguyễn Trung Kiên. He attend this conference right now. Okay. Now, so that we move to the next presentation. Mr. Huỳnh Lê Phước Sơn.
Me.
Yeah, okay.
Here, yes.
Yeah. Your presentation, the paper number 1065. Okay. Investigate the energy absorption capacity of EBS with different thickness in the motorcycle helmets. Yeah. Mr. Hindler Phước Sơn, please.
Yes, I will present my recorded video. On behalf of my team, can you hear my voice?
Yes, I hear.
Good afternoon, everyone. On behalf of my team, I'm Hindler Phước Sơn. Today, I will introduce you our research about the shock absorption capacity of EBS layer with different techniques in motorcycle helmets. We start right now. My present has 4 main parts. First of all, I will introduce more detail about helmet setting in Vietnam circumstance. After that, we study the structure of helmet to get its core feature. From that point, in the second part, some helmets are conducted experiment tests to get data to build FEA model in which shown in the third part. When we successfully optimize the virtual model in which error less than 5% to real one, we will expand to simulate with different techniques of EBS layer. The result will be discussed in the last part. In the first half of 2020, Vietnam has lost more than 3,100 people in about 6,800 accidents. According to WHO report in 2018, Vietnam is one of the most Indo-Chinese countries having people wearing helmets. Following Thompson research in 1999, head and brain can be protected better than 63% to 88% if people wearing qualified helmet. In Vietnam, QCVN 02 2008 is a national standard and shock absorption is one of the difficult and important tests in this standard. We can see the table. It's stress that depend on of size and rope height and peak acceleration. In this test, our helmet will be lifted to a certain height and drop down to impact our anvil. Our accelerometer in the center of helmet will be measure acceleration signal. To understand the structural feature of helmets, we investigate its structure. We found that today, helmets are reduced the diverse design for the different needs and purpose. But in general, their principal architecture, which consists of 2 main liners. The first is ABS cell protecting against falling objects and penetration by sharp objects. The second is EBS liner help reduce the shock to the head by absorbing energy impact. Moreover, some research EBS form is the better optimization of energy absorption cost and volume than some other material. From that point, we want to figure out which thickness of EBS liner will reduce better shock, and we start the research with experiment test. This is experimental diagram. It consists of 2 rounds. The first round, we determine the density of EBS layer, and the second round, we measure the acceleration in shock absorption test at a center in Vietnam. In the first round, the helmet will disassemble to get EBS layer and measure its mean thickness. After that, some positions are numbered and extracted to some cylindrical cell. Every cell will be determined weight, height, and diameter to calculate density. We found that its density is 93.5 kilogram per cubic meter. We compare this result with Shannon result in 2016 to find stress strain curve of this material. Shannon collected thousands of helmets to extract 63 cores of diversity EBS. From the data of Shannon, we use thin plate method to create this regression survey with density about 93.5 kilogram per cubic meter. Stress and strain we found that the Young modulus of this EBS is about 22.3 megapascal. Max stress 7.3 megapascal S 0.9 strain. Next, we test shock absorption in SHM&ES Center, a center of Department of Science and Technology in Ho Chi Minh City. This is the summarized information of helmets. The acceleration curve will be mentioned below. Here, peak acceleration is about 344 G with impact velocity about 5.5 meters per second. Follow this result, this helmet is failed in shock absorption test because peak acceleration exceeds 300 G. At this point, experimental test is completed. Next, we will continuously build 3D model to create virtual simulation. The diagram shows the simulation process. A 3D model which has formed EBS and ABS layer and anvil were created. It was imported to NSET to mesh before exporting to LS Dyna, apply, boundary, and so on. The acceleration of simulation and result will be compared to experiment test. First, a 3D model was created by using 3D scan. It was imported to SolidWorks to develop EBS and ABS layer and flat anvil. Next, a 3D model was imported to NSET to create mesh. This helmet result by using square method in NSET has formed an anvil modified by release body and simplified to reduce the size of problem. In addition, mass elements were added to make up the lost weight. 50 mm radius around the center of impact point were refined with length of element about 2 mm. Contact we use a automatic surface to surface between every part. And initial velocity were assigned to hash form is about 5.6 meters per second. This is the table show information of the model. ABS liner were assigned material mass 57 low density form of LS Dyna. The stress strain which we found in the experiment test will be used in this material. ABS and EBS layer are parts have much more elements than the other in the model. After finish on setup, the model was run in LS Dyna solver and the result will be presented by LS reports. They are the result of model. This is the stress field of ABS cell. The stress field is maximum about 91 megapascal on the cell. It's trained to move from the center impact point to the edge of the helmet with the shortest distance. This explains that some brackets in helmets often appear in this region, and this is the maximum compression state of EBS layer. The mass strength react value more than 90% at the center of impact point and gradually degree away. This is the comparison between the practical test and simulation test. The acceleration curve. The shape of two curves is similar. The difference is the time when it reacts the peak value. The deviation of peak acceleration about 2%, less than 5%. So this model is suitable to develop the EBS layers of various techniques. After solving the model with multi-technique from 10 to 20 millimeter, figure 3.2 show the deformation in max compression state. The initial thickness of each layer can affect the thickness after compression. For helmet thickness below 14 millimeter, the head form mostly collide directly with the ABS cell. We call exit point. The ABS layer has been compressed to maximum state about 99%. It's also planned that if this layer is compressed more and more, the pressure on the contact surface of EBS and ABS layer increases. This is the figure of acceleration. It's when the EBS layer change from 10 to 10 millimeter, the acceleration steeply rises, and then they react peak value rather than 300 G, especially at 10 millimeter. It's big, about 450 G. The other at the beginning, they boost as well, but then they remain quite stable over the top and go down to zero.
Yeah.
Yes, this is the final line. This is the final slide. Here the summarize chart with left side maximum trend and right side big acceleration. The big acceleration collapsed from the 450 to 354 G with technique from 10 to 11 millimeter. Then it dropped linearly to 276 G from 11 to 14 millimeter and approached a limit value about 240 G from 18 to 20 millimeter. Similar, mass strength also fall rapidly from 10 to 16 millimeter before reaching a plateau value. Therefore, big acceleration and mass strength tend to approach a certain value. The thickness of EBS layer increases, especially when the thickness is 16 millimeter or more. From this point, we wonder that whether this trend depends on the density of
Mr. Lê Phước Sang, whichly we have 15 minutes. Yeah, how many times?
Yes. This is the final slide.
Yeah.
Can you hear me?
Yeah. Please.
Yeah. For each type of EBS, it will have an upper limit value. If the thickness is rather than this value, it is a weight of material. And it also have a lower limit value. If it's less than this one, the helmet cannot meet the standard quality because the big acceleration can exceed the allowable acceleration. In this study, the lower and upper value are about 30 millimeter and 16 millimeter respectively.
Okay.
Yeah.
Thank you.
Thank you.
Any question for this presentation?
Okay. I have one question to your presentation.
Okay, Lee.
Okay, my name is Tung. Okay, please show the last slide discussion.
Yes.
Okay,
This
here
slide.
okay. Here your research, and I would like to ask you, what technique is the most efficient in your model? Because
Which
if you
technique?
increase the technique, it will your cost of the cost will be increased. So which technique is more efficient in your model?
Which technique? Can you speak again? I can hear clear.
Technique in the simulation.
I mean, what technique is more efficient in your model? Because if you increase, just my thinking, if you increase the thickness, maybe the cost of the helmet will increase. So
thickness.
Yes. The first model I use the thickness same with the experiment test about 11 millimeter. After that, I expand the thickness from 10 to 20 millimeter to resimulation, and we get the result.
Okay.
Okay.
More information, please, Mr. Tuấn, contact to Mr. Hình. Yeah. The next presentation.
Yes.
Mr. Hình is upstream. Yeah, okay. The next presentation, number 1080. It's me. Okay. Dynamics analysis of procedural structure. I can share presentation. Yeah. Okay. It's me. I present a paper titled Dynamic Analysis of Drag Drilling Structure to the Weight and Wind Loss Considering paper ballast water. The co-author with me, Mr. Nguyễn Đức Minh, Master Student, Hồ Chí Minh City Open University, and Mr. Đoàn Duy Khánh, Vietnam National University of Forestry. I am Nguyễn Trọng Phước, you know. This slide is the outline of this presentation, including a classical presentation, one introduction, two formulation, and number three, numerical investigation, and the last conclusion. Now, in the introduction part, in this figure, we introduce the Tam Đảo 05 shell drilling risk. That is the offshore structure to the petroleum. Yeah, and it's and this presentation in detail of modeling Tam Đảo 05. We have many components in this structure. Number one, risk body. Number two, lift structure. And number three, in the console guide system, and we consider in the structure, we consider the blood water. Do you know a blood water in this structure? The blood water to change water level to improve the balance of the structure in the water sea. And this is a parameter of blood water and parameter of side parameter of Tam Đảo 0.5, including blood water in the 3,000 and approximately 3,300 tons or 3,300 mixed on the body of the structure. And according to the blood water, what the blood water level go to the mass of blood water in the structure. The mass water in the structure affect affected to natural frequency of this observer, and so that dynamic response of structure may be changed. We consider in this problem. That is the next slide. In the formulation, in the slide, we can see the finite element model by ANSYS software in the platform, including the 3 column by the trustless simulated by beam element and trustless and ballast water in the body of the ballast water in the body of the structure, truss body interact by the in the back of the truss platform. We can we model it by the shell plat element and blood water and blood water. We simulate it by fluid element in the ANSYS software. That is the ANSYS software for pre-Wisman side, and we can see the FSI fluid structure interaction in simulation of ANSYS software by blood water interaction with platform of the structure. It is the property of the structure. Okay. After that, we study the waste loading and wind loading to S2 condition and operating condition, and extremely some condition, at depend on the typhoon or the tropical typhoon in the structure in the Sea of Vietnam. And that is the simulated option way. We have used in Morrison equation for to predict waste loading on the structure, including waste water density, column diameter, the parameter in this equation, a cross section of the column, okay, CD coefficient of brush bed and coefficient of inertial resistance, using area waste theory, velocity of the waste on the structure in this equation. And the last, the load on the structure in total of moment of inertia and resistance space. It can be Airy and Morrison equation in as follow. Yeah, in this equation and in this equation. From that, we move a numerical investigation of the platform of the structure. The first influence of platform on natural period frequency, natural frequency of the platform. This slide you can see in the natural periods, and this slide is the value of barriers of the structure. When the value of period of the structure depending on water, blood water level in the 1 euro to 6 meter, approximate the total blood water on the body in the from the euro to 3,300 tons. When it can be seen that when over the blood water is approximate 1 meter, when blood water level is increasing, the barrier is decreasing. You can see here when the blood water level over 1 meter, the barrier is decreasing, so that the structure in the may be stiffener. It is a next investigation in the numerical, so that we can see the horizontal displacement of structure system due to the wasting loss, due to swelling loss at operating condition, not extremely condition in the next slide. horizontal displacement, it can be seen that this area, the horizontal displacement of the structure can be reduced its area, and after that it decreasing in this area, so that from that it can be seen that we must remain water blood level it can be seen here for the consideration of operating of the system. And the last we storm it condition is generally is the same. However, the area is spent. However, the blood water level is spent. It is here, so that the response is this area. We can say that it can be seen that it reduced, and so that it increasing dynamic effect on the SHM condition extremely. Okay, that is the value of the first natural period of the structure when ballast water depth, and so that the periods of the structure, it can be seen that when the ballast water depth is 1 meter, the natural period is maximum, so that the structure is shorter, and that is the horizontal displacement due to weight or weight and wind loss. And that is the column. This column is the displacement, horizontal displacement of the structure in the operating condition. It can be seen that the maximum displacement is here, and after that in minimum displacement is here. In the same conclusion, maximum displacement is here. Approximate water, blood water, it depend on the 3 to 4 meter, and after that the minimum response, minimum dynamic response occurred by this way, blood water weight 1 meter. That is the most shape of displacement due to weight of the platform. Now, investigation. The last presentation, we would like to conclusion. The blood water level in this body of the structure had affected dynamic characteristics of the rich structure. When the water blood is around 0.6 meter to 1.3 meter, the natural frequency in very increasing. When the water level of blood water level is 1 meter, the damping effect is greater. Horizontal displacement is reduced to by 40% under operating and approximate 27% in extremely storm condition compared to risk without blood water. As the blood water level increasing, the barriers that in the density to the wave cycle dynamic effect increasing significantly. This is the reference of this presentation. Thank you for your attention.
Okay, thank you.
Any question, please?
Hi, Professor Phước, may I ask you little? Hello, Professor Phước.
Yeah.
Okay. In this study, you consider the effect of wind and wave to the drilling gig. So, and it is similar in ANSYS. So, I mean, how we can consider G loss in the ANSYS model, sir?
Yeah, I know.
I mean, how you can consider G loss in the ANSYS model?
ANSYS, we use ANSYS workbench.
But
ANSYS
I know
workbench. Yeah, ANSYS workbench model for we consider the CD and FSI. Yeah, CD. FSI, fluid structure interaction. Yeah.
Okay, I got it.
Yeah.
And another thing I would like to ask you.
Yeah.
Usually in the drill, at the construction side, the wind and the wave, I mean the direction of the environment condition is not the same. For example, wind and wave may be different. So did you consider the effect of misalignment between wind and wave?
Okay. I would like to for your question. However, in that reason is the dynamic response of the sheet structure due to weight loss and combined wind load in another design, not in consider in this presentation. However, the load, the wind load is the sensitive, not in dynamic in this.
Okay.
Yeah. Okay.
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 Okay, got it. Thank you, sir.
Next presentation. Next presentation. Paper number 1082, developing an apparatus to determine thermodifficity of bearing material with author Trần Thảo. Okay. I can see Miss Trần Thảo. I can't see Miss Trần Thảo.
Hello, everyone.
Oh, yeah.
I changed my presentations for organization.
Yeah. Mr. Thảo, please, to presentation this paper 1082. Okay.
Yes.
Yeah. Can you share this screen? Okay. Yeah, I see.
Yes.
Mr. Thảo?
Yes.
Yeah, can you presentation? I saw your background of your computer.
You can hear.
Yeah, I hear.
Yes.
Okay, I saw your computer. Yeah.
Yes.
You started, please. No volume.
Okay.
You can say.
You can hear me video?
Yeah.
Sorry, there is no audio, please. There is no audio,
Yeah.
please. Can you ask Professor her for?
In this presentation, I see, not I not hear. No sound. Miss Thảo.
Yes.
Yeah, I hear your voice. I'm not hear your presentation because that the video is not sound.
Okay.
You can say PowerPoint
The device
presentation.
include my compound success. You can hear my picture. One heater with
Yeah, I know.
heating plate and temperature controllers, and two specimen content with temperature sensor position. Yes. Position specimen, and three data recorder with engineer. Yes, engineers SHM&ES 675, and thermocouple Taika, and to extract device. I browse this device calibration, and it's possible to use the home Arduino's distinct circuits to measure the temperature in order to determine thermal diffusivity. Yes. And temperature measurement were conducted as follows with step with 5 steps in this slide. Firstly, I focus on measuring temperature and determine thermal diffusivity of upon congress. To apply the manufacturer equipment as well as evaluating the measurement methods upon congress were used to their purpose. You can see figure 7. Events maintaining similar surface temperature at the same time. The least square value are still changing as different position. This observation can be explained by the fact that the temperature sensor at different locations could be adjusted to agree have different particle size and distribution. In figure 8, the measured temperature appears to be lower than the one from calculation. This might be due to temperature loss. Therefore, ongoing study now focus on determining the amount of experimental temperature which compensates for the loss. Finally, we go to conclusion. The experimental equipment to determine thermal diffusivity for pavement material has been proposed and verified for advanced Congress. The obtained result by consultation with the ones from the previous students. namely the thermal diffusion loss upon correct 19. Therefore, it strongly recommends this device for thermal diffusion test of pavement material. And we have two ongoing studies. Yes. And acknowledgement, this study is sponsored by the University of Da Nang, University
Okay.
of Science and Technology.
Okay.
That's all. Thank you for listening. I would welcome any comments or suggestion. Bye.
Yeah, thank you. Any question to Miss Thảo? Okay. We move we go to this next presentation in paper number 1084. Influence of ground motion frequency on the seismic vulnerability of the non-structural component. Group of author Mr. Dr. Nguyễn Phú Cường.
Hello, Professor Phước. I will present on behalf of
Rồi,
okay.
Dr. Trần Thanh Tuấn presentation. Yeah.
Thank you.
Okay. Dr. Trần, please. Yeah, I see.
Okay. Okay, may I start? Hi everyone. My name is Trần Thanh Tuấn from Quy Nhơn University. Today I'm here to share with you about the influence of ground motion frequency on the seismic vulnerability of the non-structural component. And my presentation includes 5 parts. Firstly, I will talk some general information about our research, and then the numerical model of the structure and ground motion selection. And finally, I will show some main research and the conclusion of the study. And now let's move on to the first session. In this slide, I would like to introduce you about the general information of this study. And as you know, in nuclear industry, cabinet structure is one of the most popular components. And however, they are primarily designed for the functionality rather than for the seismic resistance. And during the earthquake, and this structure can be failure. And here shows some example of the failure of a cabinet during an earthquake. And another thing I would like to talk with you as cabinet facility is a sensitive non-structural component due to the attacking of the device inside, and usually they have high dominant frequency. And for the size in wood, there are some main parameters of the ground motion. For example, the bit value, or the duration, or the area intensity, or frequency. And among them, the frequency content is one of the important parameter of the ground motion, and it can amplify the structural response. So the aim of this study is how to control and protect the equipment against the earthquake lock-in. Okay, now let's move on to the numerical model of cabinet. In this slide, I would like to show the method for the to simulate model numerical model of cabinet, and here is the framework of the methodology. And you can see here, firstly, the experiment model analysis you perform, and the MOSFET and the natural frequency will be obtained. And at the same time, the numerical model analysis also performed, and we also get the natural frequency and the MOSFET of the structure. And if there is a good agreement between them, that means the model has been validated. But if there is a big difference between them, the calibration process will be conducted, and that is the process for development the numerical model. Okay. Now let's move to the experiment of the cabinet, and at the left side is the experimental setup, and then the right side is the result. And you can see here in this study, a prototype of cabinet is used, and first you can see here is the dimension of the cabinet, and the total weight is about 300 kilogram, and the main section of the cabinet is here, and it is assembled by the rectangular section and the C-shape section. And here's and the impact hammer that is performed, and here is the impact hammer, and the right figure show the result of the experiment, and here is the response at a different location of the cabinet. Three locations in the three locations shown here, and here the result for two side, front to back, and side to side direction. Another in this figure, I show the dynamic characteristics of the cabinet. We use the signal analysis, and the dynamic characteristics of cabinet can be obtained. And using this figure, we can determine the natural resistance of cabinet based on this figure. And let's move on to the modeling of the cabinet, the numerical of cabinet. And in this study, the SAP 2000 is used to create the numerical of cabinet, and the beam and the cell element is used to simulate the frame and the play element, and also the for the connection, the link element is used. Particularly, you can see here the connection between the mainframe and the play is created using the rigid link, and it's assumed to be fit at 6 degrees of freedom. And for the connection between the mainframe and the door, here is the door, and the hint between the mainframe and the door is modeled using the hint element, and it's assumed to be fit at 5 degrees of freedom, and it is considered it, and the rotation around the hint is released. And for the lock between the mainframe and the door, you can see here it is assumed to be fit at 3 translation degree of freedom. And here is the validation result. And in this slide, I only show the top response. And here is the show for the response in front to back and side to side direction. And as you can see, a minor variation between them. That means the numerical is validated. And now move on to the ground motion selection. And in this study, I see ground motion from here, and historical ground motion in Korea is selected.
Dr. Trần, increasing of your volume, your microphone. Increasing your microphone.
80 ground motion is divided in 80 ground motion is divided into two groups. First group is having a low frequency, and the second group is having a higher frequency. And here, so the response spectra of two groups, and here the first group high frequency, and here for the lower frequency. And for a better comparison of the structural response on earthquake has been scaled to a value of 0.5 G, and is scaled to this value. Here is the BGA of the ground motion for the high frequency, and here for the low frequency. Okay, now let's move to the main research. And in this slide, you can see the research. The first figure, the left figure is the maximum acceleration of the cabinet under two groups of earthquake, and the scatterborn is the maximum acceleration of the cabinet, and the dark line is the mean value. And for a better comparison, so the acceleration amplification factor is proposed, and it is defined using this formula. That means the response of the cabinet divided by the maximum acceleration of the input. And the research showed that the high frequency earthquake is greater about 3 times compared with the low frequency earthquake. And also the probability of the failure of the cabinet also performed, and you can see in the right figure, and you can see here the 50% of the collapse were found, and for the high frequency earthquake, and this value is about 0.5, but for the lower frequency, and this value is 0.7 G. And this means that for under high frequency earthquake, the cabinet is more vulnerability.
Quickly, Dr.
Okay,
Chang.
now let's move on to the main conclusions. And here you can see the conclusion of this study. And that's the main conclusion is that means the during earthquake, the cabinet is more vulnerability under the high frequency, and a factor that is greater about 3 times compared with low frequency. That's on my presentation.
Yeah, okay. Thank you, Dr. Trần Thanh Tuấn. Question, please, from the audience. Okay, everything okay. Audience can be contact Dr. Trần in the next side if considering. Yeah. Now we go to the next presentation. Paper number 1086, analysis of steel column deteriorated two directionally during seismic loading. Author of Trần Tuấn Nam. Dr. Trần Tuấn Nam, please. In this, Trần Tuấn Nam is absent in the list of author in this conference. I can't see Trần Tuấn Nam. Yeah. Now, Trần Tuấn Nam is, Dr. Trần Tuấn Nam is absent. Now we go to the next presentation. The number of paper 1089. The study of the change in temperature induced displacement curvature of precast concrete rider consider ASR deterioration. Yeah, presentation Dr. Hà Minh Tuấn. Dr. Hà Minh Tuấn. I think this presentation is rejected by Springer, so that the group author is not presentation. Absent. The next presentation is at 1019. Iron frequency calculation of the rotating multi-layer beam using the asymptotic numerical method.
Yes, I'm here.
Yeah, okay.
Thank you.
You play, yeah. Okay, I see.
Yes.
I see screen of your computer.
What
Yeah, you started. Yeah.
Yeah. Thank you. Hello, everybody. You hear me? You hear me?
Okay, go ahead.
Yeah.
Hello, everybody. I am Professor Faiza Boumediene from the University of Science and Technology, Hawaii Boumediene. I'm from Algeria. I have the pleasure to present to you my work entitled Eigenfrequencies Calculation of Rotating Multilayer Beams using Asymptotic Numerical Method. As we know, vibration analysis of rotating structures is of great importance in the process of designing and evaluating the performance of several mechanical systems in different fields as renewable energies, aeronautics, turbomachinery, aerospace. Rotating structures are usually twisted, curved, and non-homogeneous, giving rise to a coupling between the two bending movements, short ways and flap ways. In applications requiring lightweight structures, viscoelastic material are often introduced between two faces, elastic faces, to introduce passive damping. The viscoelastic structure stiffness depends on the vibration frequencies. Our work aims to calculate the eigenfrequencies and the corresponding loss factors of rotating twisted sandwich beam, taking into account this dependence of stiffness to frequencies. For that, we use the homotopy technique and the asymptotic numerical method. For my presentation, I begin by explaining the mathematical formulation. After that, I present some numerical results, and finally, I finish with conclusion. Let's consider a twisted sandwich beam with a constant cross-section. We take this hypothesis. I cite the important layers are perfectly glued together. Materials are assumed to be isotropic and homogeneous, and the shear deformations are negligible in phases. The governing equations are determined by applying the Hamilton principle. Using the finite element method, we can write the equation of motion as a function of the bending displacement parameters as follows. The homotopy technique, and we resolve, this problem is solved by the homotopy technique and the asymptotic numerical method. The homotopy technique consists of introducing epsilon parameter in the equation. Then at epsilon equals 0, we get the undamped eigenvalues problem, only R1 equals 0. And when epsilon equals 1, we get the damped eigenvalue problem. All the residual equation equal 0. The governing equation is solved by the asymptotic numerical method. To vary epsilon from 0 to 1, we use the asymptotic numerical method. This method consists to develop the unknown parameters Q and lambda in the form of integer series as a function of the epsilon parameter up to the truncation order n, where the orthogonality condition should be satisfied. The insertion of the Einstein series in these two equations, the governing equation and the orthogonality condition, gives a series of recurrent linear problems. Then, at each order G, we resolve one simple linear problem to compute the unknown parameter at order G. After that, we compute the new solution using the INM series. This new solution is satisfied up to the given epsilon by the to the value epsilon given by the tolerance fixed by the user. After several steps, and when the value epsilon equal 1 is reached, the solution of the damped problem will be reached too. The eigenvalue lambda is a complex number given as follows, where omega is the frequency, damped frequency, and eta is the loss factor. I pass to the numerical example. For this first example, we suppose that the viscoelastic material stiffness is constant. The following figures show the variation of the first 4 natural frequencies as a function of the angular speed for 4 different twist angles. It can be seen that the increase in angular speed leads to a significant increase in the natural frequencies, inducing a stiffening of the beam. The increase is clear for the first, second, and fourth modes. The twist angle has less effect on the first natural frequency, in which the curves are very close together. However, the effect is significant for the other modes. In the same way, we have represented the variation of the first 4 loss factors as a function of the angular speed for 4 different twist angles. It can be seen that the decrease in angular speed leads to a decrease in the loss factors corresponding to the first, second, and fourth modes. The twist angle always has less effect on the first mode. On the other hand, the effect is significant for the second and fourth mode. For the third mode, in the shortwave direction, the loss factor is negligible when the twist is 0, but increasing the twist angle, the mode becomes damped. In this section, we consider the same sandwich beam, but with the viscoelastic material with shear modulus here. Shear modulus varies according to the vibration frequency. The characteristics of the material are listed in the following tables. The shear modulus of the core depends on the frequency according to the Maxwell model. These figures show the variation of the first 4 depth frequencies and their corresponding loss factors with respect to the pre-twisted angle. The third mode corresponds to the shortwave mode and the others to flapwave mode. It can be seen that the pre-twisted angle has a significant effect on both the second and third damped frequencies, and also an important effect on the loss factors corresponding to the second and fourth modes. To conclude, in the present study, a numerical program is made to compute efficiently the eigenparameters of rotational twisted viscoelastic sandwich beams Our results show that the twist angle and the rotation speed have a great influence on the eigenparameters. Thank you for your attention.
Oh, thank you. Very interesting presentation. Now, any question? Question, please. Okay, I would like to a small question for you.
Yeah.
Yeah, the asymptotic numerical method in to calculate the natural frequency of the structure in the beam. Yeah.
Yeah.
This method is meant to another structure such as blood and shell frame structure.
Can you repeat the question, please?
Yeah, this method is meant to calculate the natural frequency of the another structure.
This method is used to linearize the equation, because we have a nonlinear equation here, which depend of the displacement and frequency, and we use the asymptotic numerical method to get a linear equation. When we replace this series in the equation of motion, we will have a series of linear equation here.
Yeah, series.
Yeah, which are simple to resolve, and we resolve n equations, and we will have the QG and lambda G at each order G. After that, I will construct the new solution, displacement and frequency, lambda.
Yeah.
Yes, Faiza, he means.
Yes, Amir.
Yeah. He means that this technique can be used for other structures or no?
Yeah, we can use for any equation, nonlinear equation, I can use it.
For linear equation.
Yeah, for nonlinear equation, yeah.
Yeah, because professor also working in the frame structure and the complex structure, maybe can be used also for topical.
Yeah, for any nonlinear equation, which we can write in this form, one parameter and displacement, for example.
Yeah, okay,
yeah.
Okay.
But let me just Trong ask a question for professor. So did you? I don't know. I didn't see the comparison. If you compare with the other technique or no, to make sure that this technique is more efficient.
We can use Newton-Raphson method, for example.
Okay,
but the asymptotic numerical method give the solution automatically better than Newton-Raphson method.
Okay, good.
Yeah, but because it's the same idea as the Newton-Raphson, but we with the Newton-Raphson we have Q, for example, Q equal Q0 plus delta Q.
Yeah.
Q. But here we have the series, and we have a solution automatically better than Newton-Raphson method.
Yeah.
Okay, good.
You know, Williams algorithm in this nonlinear equation for frequency equation. Williams for natural frequency of the distributed structure.
Sorry, I didn't understand your accent.
Yeah. Okay.
Can you repeat your
please,
question?
Professor Trong?
What?
Okay.
No, I mean Professor Trong. Can you repeat your question, please? I will just understand what did you ask?
Okay, that's the end of this presentation.
Okay, good.
Okay.
Thank you very much.
Yeah. In the last presentation in this session, paper number 1091, application of polygonal finite element for incompressible set dynamic soft fluid flow over objects.
Yes,
Vũ Hữu.
Yes, Kong, can you do presentation?
Yeah.
Yeah, we can finish because Dr. Vũ Hữu Trường, he's busy, so he cannot.
No, I stopped.
No, it's okay. It's okay.
So we can finish.
Kong, who will do presentation for Trong? You will not do presentation or no?
Yeah, I'm only Trường, but Trường now he's busy.
So we will ask other participants. I think there are missing missing presentation yesterday.
Okay,
yes, Ali Morteza is here.
Dr. Vũ Trường is absent at the end of this presentation.
Yeah, I know, but I think only one or two presentations.
And that's the end of this session number 5. Okay.
Yeah, I know. But
thank you for
some participants they have technical problems. So.
And then the last, according to this time, I am proposed to Dr. Lê Thanh Cường and Dr. Khazi Samir to close section. Okay.
No problem. No. Yes, Murtaza, you are not here, I think. Okay, so let me close the conference. So thank you, Professor Trong, for keeping this session. So firstly, I would like to thank all the participants for attending our first international conference on structural health monitoring and engineering structure in the civil engineering department at Ho Chi Minh Open University. So firstly, I would like to thank the honorary chair rector of Ho Chi Minh Open University, Professor Nguyen Minh Ha, for the support, and the chairs of our conference, Dr. Kong, Dr. Trong, Dr. Tin Boy, without forgetting the keynote speakers, Professor from Stanford University, and the Professor Rao Vekenta from National Institute of Technology, Surat, India, for the interested and the wonderful presentation. So for this conference will be held at Da Nang University in Vietnam. Hope can we meet each other next year in August and enjoy together with the next conference. So for the proceeding, Springer, they will contact you as soon as possible for the proof, and it will be online before this April. So also other thing for the participation letter, we will send to everyone within this week via email. So thank you very much for everyone. So if Kong want to say something, so you can say.
Yes, thank you, Dr. Samir. And I'm very happy to know that after today's our conference already been success, and there are many interesting presentations. And furthermore, I want to inform to all participants that our conference will be organized in the next August at Da Nang University of Science Technology, and I hope to see all participants again in Da Nang. Yes, and thank you all. Yes, thank you so much.
Okay, thank you. Bye.
Yeah, bye.
Okay, bye. Okay, bye.
So we see you in Da Nang.